So we have cosine alpha minus beta multiplied by cosine alpha plus beta. They claim that this is cosine squared alpha minus sine squared beta. Okay, so let's give it a shot. Any suggestions? How do I start? So can I recycle these then? Any questions on the previous lecture? Oh, they're right here. We can always go back to them. Okay, any suggestions where to start from, please?
The left.
Good. So the left-hand side equals. We have to express or use the identity for these two. Anyone remembers or anyone would like to give them to me so I can write them? The cosine alpha minus beta and cosine alpha plus beta. Anyone would like to dictate?
Would it be cosine alpha cosine beta plus sine alpha plus
Excellent.
cosine beta?
Yes. Excellent. Very good. And then multiplied by?
Cosine alpha plus beta.
So it's times cosine beta, right? But minus is the same thing. But this one is, remember, the cosine is a little bit twisted, meaning, so cosine alpha minus beta has cosine alpha cosine beta, but plus. If this is minus, this is plus, sine alpha sine beta. Now we're looking at cosine alpha plus beta, so it's exactly the same thing, but instead of plus, it's minus. So it's cosine alpha cosine beta minus sine alpha sine beta. Good. Any suggestions now? What should we do? What will be the next step? I have to multiply basically, as you see here, a plus b times a minus b. Is there something we remember from a long time ago concerning a plus b times a minus b?
Is it a squared minus 2ab?
Careful. Not to confuse it with a plus b squared, which is 3 terms, or a minus b squared, which is always 3 terms, also 3 terms. So we're talking about a plus b. Yes?
The a squared plus b squared.
Careful. It's the difference of squares. The a squared plus b squared is not factorable without using imaginary numbers. So this is not factorable using integers. So not factorable. So a plus b times a minus b is the difference of squares. The sum of squares is not factorable using integers. So what do we write?
A squared minus b squared.
Excellent, thank you so much. Good. So then I have to square this. Cosine squared alpha cosine squared beta and minus sine squared alpha sine squared beta. Good. Next step. So let's notice one thing. This is not cheating, right? But we have to look at where we have to end up. So I want cosine squared alpha, oops, which is okay, but I don't want this. I do want to keep sine squared beta, but I don't want this. So how do we proceed? So leave this alone. And let's play with this and with this. So cosine squared beta, what can it be replaced by?
1 minus sine squared beta.
1 minus sine squared beta. Excellent. What can sine squared alpha be replaced by?
1 minus cosine squared alpha.
Good. So let's see what happens. How from here we get to that. So I'm going to jump over. Of course, I don't want to confuse you with that equal symbol over there. Good. So let's continue. So we have cosine squared alpha multiplied by 1 and cosine squared alpha multiplied by sine squared beta. Okay, so minus cosine squared alpha sine squared beta minus sine squared beta times 1 and minus sine squared beta times cosine squared alpha. So minus minus plus. So we have sine squared beta and cosine squared alpha. Ah, that's exactly what I was hoping for. So sine squared beta, cosine squared alpha with minus in front, sine squared beta, cosine squared alpha with plus in front. So that's exactly what I was hoping for. So this is cosine squared alpha minus sine squared beta, which equals the right-hand side. Very good question. Thank you. Any questions on any of the steps? Is this okay, everyone? Don't be.
Most of this just you need to know like the identities on the paper that were on what the handout.
Yes, but the thing is, the more you practice, the better you get at using them, and you will not have to use your notes or your list of formulas or identities every second, because then you may not be able to get to where we're going. So these two come from the basic identity, the Pythagorean theorem, basically, right? So we know these from a long time ago, because it's sine squared plus cosine squared is 1. So these should be at the tip of the finger. Now the sum of the difference, cosine of a difference of angles and cosine of a sum of an angle, we covered these last week. Good. Perfect question to start with. Anything else you need help with? Anyone? Anyone? Any help? Any questions?
Can we go over 96?
Of course. From the same page?
Yes.
Okay, perfect.
Can
90.
we also go over 40 after that?
Yes, and 40 after that. Good. 96. Is it on the next page? Is it the same page? I mean, the same section or a different section?
This page before that.
This one here, 96?
Yeah.
Okay, perfect. So in 96, we have sine theta minus cosine theta equals negative the square root of 2 over 2. Perfect. Okay. So in this case, oh, I'm sorry. Let's read the question. It's always smart. Solve each equation on the interval 0 to 2 pi. Good. Okay, so theta is between 0 up and not 2 pi. Perfect. Okay, so if you remember, we looked last time at a similar situation. So when we have sine and cosine, you can say, but what do you see in front? Well, yeah, I see 1. But I have to replace this 1 by something else. Well, what angle has the same sine and cosine? There is only one angle that has sine of that angle equals cosine of that angle. There is only one. Which one?
Pi over 4.
Pi over 4, indeed. So when I have sine and cosine, I have to manipulate this somehow. There are other situations in which we may have to divide both sides by sine or cosine, but not in this case. If you try to divide, you're going to get in trouble with the right-hand side. So that's
It's
not...
only negative square root of 2, not negative square root of 2 over 2.
Oh, I have a very nice way of inventing stuff, right? Thank you. I don't know why I copied negative the square root of 2 over 2. Thank you very much. So back to the problem. Knowing that sine and cosine are always the same number, which is the square root of 2 over 2, I'm going to multiply both sides by the square root of 2 over 2. Okay, so let's see what happens when we do that. So I have the square root of 2 over 2 times sine theta minus the square root of 2 over 2 times cosine theta. And when I multiply these two, I get negative. This is 2 over 2, which is 1. Nothing happened. Multiplying both sides, each and every term by the square root of 2 over 2 did not change the solution. But now I have to decide whether I want to look at sine alpha plus beta or minus beta, or cosine alpha plus or minus beta. I can use either one. Of course, keeping in mind the negative in the middle. So if I use sine, then I have minus, but if I use cosine, I will have the plus here. So I don't want to confuse you. Let's go back. So these two have to be replaced by something, so I can use one of these two. I can replace sine sine or cosine cosine of pi over 4. It doesn't matter which one, but we have to choose one. Very good question. Thank you for asking that. So this has to be replaced. Either sine cosine or sine cosine. It doesn't matter. They are the same. But we have to choose. Which one would you like to work with? Maybe it would be easier. Yes, go ahead. So you want to use this as sine or cosine? Okay, very good. So I have here sine pi over 4. Then this one has to be cosine pi over 4. Good. So we rewrite the equation. Cosine pi over 4. Sine. Sine pi over 4 times sine theta minus cosine pi over 4 times cosine theta. Since I ran out of room, I'm going to write here -1. Good. So now let's take a look at the right-hand side and replace it. Since it's cosine, cosine, and sine, sine, then of course we have to use cosine. There is no other option. Now, remember the formula requires minus in front of sine, not in front of cosine. No, that's the easiest thing we can do. Multiply both sides by -1. So then, cosine pi over 4, cosine theta minus sine pi over 4, sine theta equals 1. Can anyone replace this by what it equals to? So this times -1 is positive, this times -1 is negative, this times -1 is 1. Now we have to think of how to condense this. Cosine pi over 4 cosine theta minus sine pi over 4 sine theta. What do we replace this by?
Is it just cosine?
Yes, yes, yes. Of what? Excellent. Cosine of?
Pi over 4 and then theta. No?
Cosine pi over 4 What do I put if it's minus here? What do I have inside cosine?
Is it positive?
Excellent.
Oh, okay, okay, great.
Excellent.
I was missed that.
And then
And then, yeah.
exactly. Perfect. Perfect. Let's stop for a moment and see if you have questions. Is this okay? Please ask, don't be shy. Is this okay?
This is fine, but I just want to clarify. You could have done like when you replaced root 2 over 2, and you can like flop them. Like you could have put cosine of pi over 4 where the sign is now.
Yes, that's what I said. We can use either one. Yes, you could have
Okay.
written, yes, you could have written this as cosine pi over 4 and this as sine pi over 4.
Okay.
Yes, I'm gonna just leave them like that, but I will just fade them out a little bit just to make sure that everyone understands that we really use this. But this is also possible. Yes, because it depends on what you want to use. Do you want to use cosine or you want to use sine? Yes, awesome, good. So now we go back to the unit circle. Where is cosine 1? Where is cosine 1?
At 0.
Yes. Cosine is 1 is at 0. Cosine 0 is 1. Perfect. So then pi over 4 plus theta must be 0. So then theta equals negative pi over 4. Any questions? Now, because they are telling us that theta is an angle between 0 and 2 pi, and because negative pi over 4 is right here in the middle, but they want us to present a positive angle, we will write that the solution is theta equals. Can anyone give us the solution that is equivalent to negative pi over 4, but it's an angle between 0 and 2 pi?
Seven pi over 4.
Thank you. Thank you very much. Any questions?
Could you go to the previous page?
Yes, of course.
Can you explain can you go over again the -1 equals sine pi over 4 step?
This one?
Yes. please.
So we multiplied both sides by the square root of 2 over 2. Why? Because I realized that these two numbers are equal. If these two numbers are equal, 5, 5, 5, 10, 10, 1, 1, they are equal. I have to use the only angle whose sine and cosine are equal. There is no other angle whose sine and cosine, of course, in the first quadrant, that's, this in the positive unit. And I mean, there are other angles that have, right, pi over 4, 3 pi over 4, 5, and so on and so forth. But we're talking about the positive situation in which sine and cosine are positive the square root of 2 over 2. And that's the only quadrant where both are positive. So pi over 4. So because these two are equal, I can only think of pi over 4. There is no other angle. So I multiply both sides by the square root of 2 over 2 because sine of pi over 4 and cosine pi over 4 are equal to this. So multiplying term by term, both sides by the square root of 2 over 2 did not change anything. So the square root of 2 over 2 times sine theta minus the square root of 2 over 2 times cosine theta. I have to multiply the right-hand side as well. Negative the square root of 2 times the square root of 2 is 2. 2 over 2 is 1 with minus in front. Now, we decided to replace this by sine pi over 4, which is correct. Sine pi over 4 is the square root of 2 over 2. We decided to replace this by cosine pi over 4. And now here's what we have. sine sine minus cosine cosine. And we wrote them here again. We wrote the same equation one more time. So sine sine, sine pi over 4 sine theta minus cosine pi over 4 cosine theta. Because this is no formula, and because it's not in the correct order, I multiply both sides by -1. This times -1 is positive, this times -1 is negative, this times -1 is 1. Now we were able to condense this. We're able to condense this into cosine pi over 4 plus theta equals 1. Then we went back to the unit circle, and we realized that cosine is positive 1 only in this point, between 0 and 2 pi. And we have pi over 4 plus theta equals 0. Now, I could also write 2 pi as the option. So pi over 4 plus theta equals 2 pi. And then theta would be 2 pi minus pi over 4. And that's exactly what we have. Anyway, it's the same angle. Is there anything else that I need to go back and explain here? Is there anything else that you would like to go back to? Any questions? I know we have to look at number 40. Anything else?